Alrighty. Total characters in string after transformation. I'm pretty sure this was I saw this on a contest at some point. But anyway, I'll still try to do it again. You're given a string s and integer t representing a number of transformations to perform. In one transformation, every character n is replaced with, according to the following rules, replace if the character z replaces a to b, otherwise replace it with the next character in the alphabet. A is replaced with b, B is replaced with C, so on. Return the length of the string after T transformations. Since the number might be large, use modulo 10 to the ninth. So 10 to the ninth plus 7 is the constant here. After T transformations, every character is replaced. So if T is 2, then you place A with B, B with C, C with D, Y with Y with Z, this Y with Z, so yeah, B, C, D, Z, Z, and then the next one will be C, D, E, A, B, A, B. Alright, and then there's a lot of transformations. So there's a lot of characters and a lot of transformations. I think, okay, so I think the simplest approach would be to have a like a brute force approach would be just have a character array of the counts of each character and then iterate through for each transformation what happens to each character, like A becomes B, B becomes C, so the counts of A decrease by 1, the count of B increases by 1 if there's a single A. But that probably is just going to be too slow. It's probably just going to be too slow because you're doing, at that point, 10 to the 5th characters times 10 to the 5th transformation, so that's like a million, no, 10 to the 10th, so that's like 10 million operations, and that's just too slow. So the question is how to do it quickly, how to come up with the number of A, B, C's, and D. So what happens? So how do we shortcut the loops? I think you still need to know the number of initial characters there are. So let's say the initial counts is going to be counter on S. So this is how many of each initial letter, because that definitely is going to make a difference. And then each iteration Z increases the A and B. So let's say you had something like 3 Z's. That becomes A, B, A, B, A, B. And then eventually those become like Z or YZ, YZ, YZ at some point. And then that becomes Z, A, B, A, Z, A, B, Z, A, B. And that becomes, like, this is all kind of in some number of transformations. A, B, C, no, A, B, B, C, A, B, B, C, A, B, B, C. Right. Each Z is replaced with A, B. this is like 4, 4, 4. Z's become 2. That is staggered in terms of it's not going to become 2, or each Z is not going to become just like 2 A's. So there's a bit of staggering here. And the order doesn't particularly matter. Like it could just be like if it had 3 Z's, it's like eventually it comes 3 Y's and 3 Z's. And then the Z's there become additional. Huh. So I think maybe if I were to take 3 A's, becomes 3 B's, eventually becomes 3 Z's. Hmm. Find the final length of the string after the transformations. I think so for each character, there's going to be some number of transformations. For each initial character, it's going to give some amount of ending characters given the T transformations. For each character, there's going to be some amount for each character. By character, I mean like for each alphabet letter. The T transformations will create some final amount of letters. Will contribute some final amount of letters. I feel like this should be one pass. So you just need to determine like a single A, how many final letters that A makes, or single B, how many final letters this makes. So let's say there's like, let's say you're dealing with just the string that is the alphabet ABC to XYZ, and the number of transformations is 1,000. So okay, let's do a few transformations. going to be ABC to XY or YZ AB. No, there's no B. It starts with B. BCD. And then the next one will be CDE to Z. The Y becomes the Z becomes another AB. And the next one becomes DEF. And this is AB. So it never shrinks, right? It never shrinks. And it's increasing by 2 each time. No, it's increasing by 1 each time. The Z becomes, one more Z becomes like a AB. It's increasing by 1 each time. But that's the current setup. But here I have my number of Z's stays the same. At this point anyways. But if I were to rearrange this, this is right now AB, CDE, all the way down to, wait, I'm not doing this correctly. This Z becomes, this Y becomes Z, this Z becomes AB, and these AB becomes BC. So it is currently increasing by 1. This A becomes B, the two B's become C's. But then at some point increases by more than that, because you have at some point like 2 Z's at the end. So there has to be some shortcut here. The Z becomes an A and a B. Maybe it's the time it takes for a Z to become another Z. Time it takes for each letter to become a Z. And then that Z to cascade over to another AB. So if I think of it as let's say the transformations is two Y's become Z's. So it's going to take one transformation to make this a Z, 2 transformations, 3 transformations. Okay. I can think of it as an offset from the number of transformations it takes to become a Z, and then figure out maybe what the Z does. So if I figure out what the end result is based on just having Z's, then it's just going to be some offset from that. Okay, so let's narrow down to how do Z's perform. So if I have one Z, the next time the length is going to be an A and a B. and then the length from there eventually becomes a YZ, right? Okay. So that's going to take like 25, 20, A to Y, B to Z. A to B is 1, A to Z is 25, A to Y is 24. It's 24. A to B is 1. That's 1 to first the second letter of the alphabet. A to Z is 20. A to Z is 25. A to Y is 24. So this takes 24 for okay. It takes 24 turns before the Z. What am I trying to think of here? The Z is going to be the same size. Z is going to be the same size for 24 turns. And then on the 25th turn, it's going to be ZAB. So what does that mean here? So the length here is 1. So it's like 1, and then it's going to be length 2, and then it's going to be length 3, right? Y becomes Z, Z becomes AB. And is that going to be God, I don't know if this is right. Z becomes hmm. So YZ ZAB. So this is a fresh C. AB. So this is like Z, AB, BC, YZ, ZAB. Then this is like Y. Ooh. That's 3, and then this is Y. No, this is A, B, B, C. Actually, it's 4 here. Shit. So there's only one turn where it's actually 3. It goes from 1, and there's like 24 turns where it's. There's 24 turns where it's 2. 1 turn where it's 3. And then some number, probably some number more turns where it's 4. And then like maybe, I don't even know. So Z replaces itself. Can I just model the Z, the single Z, over those many turns? Probably not. Well, each turn for some number of z's, if I start with 1z and I had an array of turns, of transformations basically, then I can maybe fill out the number of z's after some number of transformations in the future. So for instance, if I had one z at turn 0, that's going to lead to having 1z 24 turns later. So I just increase the number of z's in the array 24 spots later. And also 25 spots later, because that z becomes, eventually the z becomes AB, and then interesting. So maybe if I just count the number of z's at any given time, count the number of z's at any given time. So say my array is turn 1 to, or I guess this is indices 0, 1, 2. So there's 1z at this first spot, and then I fast forward and I say that since there's 1z at this spot, that leads to being 24 spots later. So that's at 24, there's another 1. And then at 25, I say there's another 1. So this 1z leads to these 2 z's here. Or if this was like, 3 z's, then there'd be 3 z's here and 3 z's here. So I just map where the z's are. And then how do I calculate the total number of letters though? So if there's 1z here and there's 1z that leads to z here, in between them there's some number of non-z's that it's like mapping to, that's rotating through like a through y. How do I take that into account? So how do I know, like, say, eventually get to 1,000, and there's some number of z's. I don't know. There's some number of z's over here. At 999. But I didn't fill anything here. So if there is a z here, then every spot here is gonna be, what? If there is 3 z's here, then that implies that there should be 3 3 non-z's for everything after it. There's 3 non-z's for everything after it. That's not increasing, that's just the number of, so let's say you start with 3. So this means that in terms of, if the z's are like that and the non-z's, there has to be like 3, 3, okay. The indexing is 3, 3, 3, 3, 3, 3. And then what happens when I see another z? Because it doesn't actually mean that there's 3 non-z's here. Because this one z is not a new z. This is an old z. The y became a z. So when I see a new z, I decrease. Do I decrease at all? When I see a new z, that doesn't affect the count immediately. Yeah, that doesn't affect the count immediately. It affects the count after it. So if the number of z's is initially 1, like these are the initial count of, so the number after is going to be 2. So if I see a z, these z's don't affect anything, because that just meant that something transformed into a z. But then the one after it is going to increase by the number of z's. And then this will increase again to 4 because there's a 1 here. I think that works. So keep track of the number of z's in an array, and then I do this pattern with the length of the thing. And then I do some offsetting. There needs to be some offsetting for the initial things, initial letters to get to z's, I think. Okay. Okay, so let's say I have my z count array, and let's say I have my non-z's array. I guess if I have my z count array and I fill that out, then the second pass through is just the count. So I don't think I need this. I don't think I need to track that as an array. So, alright, so let's say my z count array starts with the counts of the z's from the thing. So I'm ignoring the offsetting. I'm just trying for the number transformation or the length of the thing if it's a bunch of z's at the start. And my z counts array is actually should be the length of the number transformations. 0, 0. And z count of 0 is equal to counts of z. And then for each t, each index in range of t, the number of z's at this. So it's gonna, so current count is going to be equal to z count at this index. And I guess I need to not go out of bounds here. If so, I can make an if statement to not go out of bounds, but actually what I'm going to do is I'm going to hack it and say that I'm just going to increase my number of transformations. I'll just extend out the array so that I don't have to do an if statement each time. So, I don't know, another 25. So z count of index plus 24 is equal to the current count plus equals the current count. And z count of index plus 25 plus equals the current count. Okay, so the 1, yeah, it becomes 24 and 25. Okay. And I think that works if I have plus 25 here. Okay. And then what? So now I need to go through it with the non-z's. So for each index, actually maybe I can do this in one pass. I can do both calculations in one go. I think that might work actually. If I'm going to assume that the answer starts out at index plus 1 or index 1. I don't want to so if it's 1, the answer, if I'm at a certain index, the answer is going to be incremented by the number of z's in the previous spot. I don't want to make an if statement for that, but maybe I have to. Or I can just make another array and then make another array. Fine, I think I'll make another array. Let's say its answer array is going to be, the answer array is going to be 0 times 2 plus, should be times t, and the answer should initially be also the number of z's, and then the answer plus 1. Okay, maybe I do transformations plus 1. So answer at the next index is going to be incremented by the current count so there needs to be running total, right? Running total. So actually this should be total is currently that, and then the answer The total is incremented by the current count, and the answer index plus 1 is the total. I don't think this is very efficient. Return the answer at t at one transformation, at t transformations. Okay, let's try this out. Let's go with 1z, 1000 transformation, 3z's at 1000 transformations, and 5z's at 10,000 transformations. Oh, I probably need to use the mod like they told me to. Answer total equals total plus count mod. Mod all this. Okay, not correct. Let's go something smaller to see if I did it at all correct at any point. So say 20 times 2 and 25. Okay, well that should be correct, right? So it's just 2. Becomes 1 becomes 2. 25 is 3. Is this offset by 1? Should 25 be still 2, right? Yeah, this should be still 2. And then this becomes 3. Okay, so let me go ahead and look at the. Let me go ahead and print out the for every index in range t print index z count at the index. Okay. I wanted to look at this case. So this seems okay. I want to do t plus 2. Okay, is this what I expected? Yeah, that's what I expected. Number z's is 1 at 24 and 1 at 25. So the answer at the index. Am I doing it the wrong time? This 1 should increase, make this a 3. Uh, 24. Z becomes, in 24 cycles, becomes another Z. Is that correct? the z in 24 cycles become another z? I think so. The z in one cycle becomes ab. The z in one cycle becomes ab, and then it takes another 24 cycles before the b becomes a z. I think it might be offset by 1, actually. I think this might be 25, 26. Yeah, I guess that makes sense. The single z becomes another z, like the ending z in 26, right? Okay. Out of range, I think this needs to be plus 26 then. Okay, good, good, good. So if I have some number z's to start, this quickly calculates, I mean quickly, relatively, it does a full pass of all the transformations. I think that's probably necessary. Okay. So it gets it correct for if it's all z's at the start. So I just add in like non-z's. Just need to add in non-z's. So I think my answer should actually be the number of letters initially instead of 0. So the total should start out as the count of letters, which is just the length of s. And then I need to fill out my initial array. So for every letter in my counts, I'll say the offset from that letter to when it becomes a z is going to be equal to the ordinal of the letter. The ordinal just converts it to a number. Minus ordinal of letter A of letter Z minus ordinal of this letter. The ordinal of letter Z minus the ordinal of this letter. Yeah. So if it's Z, then it'd be 0. And if it's Y, then it'd be 1. This is number of transformations before letter becomes a Z. And then the Z count at this offset is initially equal to the number times this letter occurs. I think that might be it. And then yeah, that might be it. Huh. Okay, dokie. Let's comment this out. Don't need to print out. Let's see if it actually runs fast enough. Alright. There were things faster. Let's see if I can think of how to improve this. So you definitely need to know how many of each letter there are. I think this is fine, just to increase the length of it so that you don't have to do an if statement to go out of bounds when you do indexing plus 25 plus 26. I don't think this is necessary actually. Your initial z count is not going to be this is taken care of inside the if state, inside the for loop. So initial answer array. Do you need that? I mean, can I somehow do without this answer array? Your initial answer is your total, right? Your total. So what is the question? Let's say if t is equal to 0, then just return the length of the string. And then you just need to do this t minus 1 time. Why would you do it t minus 1 time? You have to do it t times now. Do t times, and then you just return the total at that point. Answer index plus 1 is equal to total. Yeah, I think you just return total mod. I think that works. Yeah, okay. So I can get rid of this answer array. This is kind of poorly. Let's say z ordinal is equal to ordinal z. We can maybe do this as z ordinal minus that. Number transforms, full letter becomes z. Transforms to make letter to z. Z count is equal to 0. No, that's necessary. I could probably just get rid of this here. Current count is Z count at this index. Yeah, I need the indexing. Yeah, can't just do it for each loop. Z count at this index. Is that the correct? Yeah, that's correct. And I think that's as cleaned up as I'm going to make this. Z count, Z ordinal, letters offset. Yeah, it's cleaned up as I think it's guts. Yeah. I don't know why or how I could make this better, faster. Some people definitely did 310 milliseconds. All right, let's take a peek. Whoa. Count of the items. So they have a dynamic programming array. Interesting. So they said that at each, so I think this is still the number of z's, same thing as me, maybe. They assumed that you had one z to start with, basically. Or maybe this is you assume the length is 1. So they didn't need to care about the number of z's, they just said the length. So they said if the length is 1 to start with, then they're mapping the number of letters that you get after some number transformations. So the number of letters after the ith transformation is the number of letters after 26 spots less and 25 spots less, because I think it doesn't matter. Yeah, it doesn't matter number of z's at all. And then all this the things whenever I read other people's codes or the solutions, the thing that strikes me is how they try to optimize for conciseness at the expense of readability, or at the expense of just uncomplicated code at some points. Like, you really don't need to have an expression that is this complicated, I don't think. Like, if you break this down, it's not going to hurt your code's efficiency, but helps other people understand your code a lot better and improves things in the long run, I think. But regardless, I'm fine with what I did. I think it makes sense in my head, even if it's not extremely optimal. Alright, so the summary here, so I'll preface to say this is my way of thinking about it. There are others that can be more efficient / optimal, but here is basically I thought about determine the length after t transforms for starting with some amount of z's. So if the number of z's is tracked in a t-sized array initial, where the array at 0 equals initial count of z's, and then array at k will become since each z will become another z, 25 and 26 transforms in the future, then therefore array at k will be equal to array at k plus 25 is equals plus equals, and array at k will plus equals array, or that's the other way around. Oops. Array at k plus 25 will plus equals array at k, and array at k plus 26 Okay. um, thus you'll know how long. Thus you'll know how many z's will appear after k transforms. For each z in array, array increases, length increases by that number post transform. Then basically keep track of total length. So fill out initial array by determining offset between any non-z letter and when it becomes a z. So for example, an initial a is 1z, at t equals 25. So our array equals array of 25 equals 1. Keep track of total length while passing through the transform array. Alright. Yeah, so you have your initial count of you have your initial array, there's z count. You have your initial total of all letters, and then you determine for each letter how long it will take, how many transforms it takes before it becomes a z, and then you make that your initial count of z's at that input, at that index. And then as you go through all the transforms, you increase the number of z's at later date, and you keep track of the running total, increasing it by the current z count at this index. Time complexity, this is O of t. Yeah, this is O of t, as this will pass through all transform amounts to determine z count and length. Space, this is O of t, to keep transform array. Technically, this goes, there is a second loop here that goes through all the letters. O of A, where A is the number of letters, alphabet. So technically this is like O of the maximum of t versus A. Overall, if transforms is less than, if t is less than A. Actually, I am kind of curious as to what I did like so long ago. So I actually did this in October. Pretty sure this is for a contest. So what did I do? So letter. So I did the same offset deal. For each transform and for each letter, the counts of interesting. I guess this is worse. This is O of t times O of a. O of transformations times O of letters. Yeah, this wasn't strictly necessary if you did the offset to start. Yeah, whatever.